Welcome to Day 33 of Math 111. In this lesson, we will be discussing ratio and proportion. We will begin with ratio. A ratio is simply a comparison of two quantities. Our definition from our book tells us if A and B are real numbers with B not equal to 0, then the ratio of A to B is the quotient A over B. Here's an example. Suppose that a coin is flipped 20 times with outcomes of 8 heads and 12 tails. The ratio of heads to tails is 8 to 12. You may have seen a different notation in the past dealing with ratios. Sometimes a colon is used. We could express this same ratio with this notation 8:12. It is read the same way, 8 to 12. Here we have our example repeated about the coin being flipped. We have at least 3 applications of ratios that we want to mention here, and 2 of these applications deal with this example. The first application, a ratio measures the relative size of different parts. So in our ratio 8 to 12, we're thinking about the size of the different parts here. So the ratio of heads to tails is 8 to 12. This is telling us about the size of the parts. A ratio can also measure relative size of a part to a whole. Our coin was flipped 20 times, and we had 12 tails in the outcomes. So we could think of this ratio of tails to the number of flips is 12 to 20. So these are 2 applications. We have a third application that we could talk about, and it deals with rate of change. Ratio measures the rate of change in one quantity with respect to a corresponding change in a second quantity. Our example with the coin does not apply here, but let's look at another example. Evan ran 3 miles in a half hour. The ratio of distance to time is the rate 3 miles to 1/2 hour, or 5/10 of an hour. When we simplify this, we get 6 miles per hour. This is a rate. We talk about miles per hour a lot when we talk about how fast something is going. This is an example of a ratio as well. A ratio can give more information than is immediately obvious. Let's think about this example. The local pet store sells only puppies and kittens. Today, the ratio of puppies to kittens is 19 to 26. So based on this ratio, we know that there are 19 puppies in the pet store and 26 kittens. The question is, how many total animals does the pet store have to sell? When we add the puppies and kittens, we realize that there are 45 animals that the store can sell. Here's another example. The local pet store sells only puppies and kittens. Today, the ratio of puppies to all the animals is 28 to 44. So we know that there are 28 puppies and 44 total animals. The question is, what is the ratio of kittens to puppies? We can find the number of kittens by subtracting. We take our total of the animals, 44, and subtract the puppies, 28, to get 16. So there are 16 kittens and 28 puppies. Our ratio of kittens to puppies is 16 to 28. Up to this point, we have not simplified any of the quotients that we've seen. A ratio can be expressed in simplest form. So the ratio 8 to 12 can be simplified to 2/3. In the original form, we understand that each number has some significance in terms of the problem. When that ratio has been simplified, we lose that original information. But we do have an advantage because now we see relative size in more tangible ways. I think it is more understandable to think about 2/3 than 8/12 in terms of relative size, since we're familiar with 2/3. Let's talk about a proportion now. If A over B and C over D are two ratios, and these two ratios are equal, this equality is called a proportion. We have a theorem related to this. The equality, A is to B as C is to D, is a proportion if and only if A times D is equal to B times C. You'll notice that we have cross-multiplied here. We have the product of the extremes, A and D, is equal to the product of the means, B times C. In order to solve a proportion, we cross-multiply. We may know 3 of the numbers involved and are looking for the 4th number, as in this case here. We have a proportion set up. In order to solve it, we'll need to cross-multiply. We'll multiply 65 times 6, and we'll also multiply 78 times x. We use our normal algebraic operations in order to solve this. 65 times 6 is 390. I will then divide 390 by 78 in order to find x. 390 divided by 78 is 5, so x is equal to 5. Proportional reasoning is a topic that you'll find in the mathematics curriculum in various grade levels. Let's look at a problem dealing with proportional reasoning. Suppose that Marilyn's car used 15 5/10 gallons of gasoline when she traveled 496 miles. Approximately how much fuel will her car use when she travels 650 miles? We want to move now to proportional reasoning. Proportional reasoning is a concept that begins in elementary school and it continues all the way through high school. Here's a problem. Suppose that Marilyn's car used 15.5 gallons of gasoline when she traveled 496 miles. Approximately how much fuel will her car use when she travels 650 miles? We will set up a proportion in order to solve this problem. We'll begin with a ratio of known values. We're told that the car used 15.5 gallons when she traveled 496 miles. So our ratio will be 15.5 gallons to 496 miles. We'll set up the second ratio with the same quantities in the same positions as in the first ratio. We're looking for the number of gallons. That will be in the numerator. And our new mileage is 650 miles. So our second ratio is x gallons to 650 miles. After setting up the proportion, we can cross-multiply. So you'll notice that I'm multiplying 15.5 and 650. On the other side of the equal sign, we have 496 times x. Again, I use my normal algebraic processes to solve for x. I multiply 15.5 times 650, and then I divide by 496. We were asked to approximate the amount of fuel that would be needed. I've rounded to the nearest tenth. So I have found that in this problem, x is equal to approximately 20.3 gallons. Proportional reasoning, as we mentioned earlier, is a concept that is present in mathematics from the middle grades through the secondary. The concept of using proportional reasoning to solve a problem is a major concept in calculus and other higher level mathematics courses, and we see it in the sciences as well, in physics in particular. The concepts of ratio and proportion are very important for our students. Go back and review some of this if you are unsure of yourself.